All right, good morning. So I'm Jonmichael Hands. This talk is about incentivizing circularity, redefining carbon accounting in the ICT industry. I co-lead the Carbon Accounting and Circularity Project in OCP. I am also the secretary and treasurer of a 501c6 nonprofit called Circular Drive Initiative, where we talk about all things sustainability for storage. And my day job is a product planner at Fadu, where I'm looking at PCIe Gen 6 SSDs for use in hyperscale data centers. So I am actually a storage technologist. I do not have sustainability in my job title, like some of these folks. But I have been really active in OCP Sustainability Project since the start. One of the things that we did, this was like almost maybe a year and a half ago, was right when sustainability became the fifth tenet. We wrote a white paper that is on the OCP website that kind of defines what sustainability is to the ICT industry. And this was one of the things that we found, like the audience for this white paper is mostly the other projects and other work groups at OCP to understand how we think about sustainability. And the first big one is about transparency, reporting, metrics, one for data center operators where you're talking about scope 1, scope 2, scope 3, and then one for suppliers where you're talking about generally life cycle assessments. And circularity and reuse, we did two major projects for circularity and reuse. We had a media standardization white paper that kind of went through like some of the major barriers and gaps for circularity and what was preventing circularity in the ICT industry. Specifically a case study on storage, which I mentioned. My day job is in storage, so that's what I'm going to be talking a lot about today. And then we have a design for circularity guide, which is a guide for product managers to basically look at how they can make their products more circular. And one of the big gaps that that we saw was there is no bridge between this reporting and circularity. And circularity is just like, okay, it's a nice thing to do. We just talked about potential carbon avoidance. Makes sense if you can use a recertified product or refurbished product that that the extension of use could improve the greenhouse gas reporting and the carbon emissions. But there is no proper way to do that. And that's going to be the talk of today's talk. The last part is the efficiency and interoperability. I think the majority of people I see in the ICT industry that talk about sustainability are really kind of mix up energy efficiency and sustainability. They just say, hey, look how sustainable we are, but in reality, they're just talking about energy efficiency. It's one very important piece of sustainability strategy. So this was the latest 2024 sustainability report from Meta. And this is not dissimilar from the last year where, as you can see, the overall overall emissions, 8 million metric tons of CO2e, and almost all of it is scope 3, right? They have renewable energy in their data centers, they have offsets, and even the carbon credits that they have purchased, it's like in the 50,000 tons range, right? When you're looking at 8 million tons of, you're not on the same universe, right? There's just not enough carbon credits. And so these net zero programs and some of these hyperscalers are looking for carbon avoidance programs for, we actually went through our nonprofit, submitted an RFI for some of these hyperscalers, and I learned a lot about how they thought about this carbon avoidance. And they're just looking at this graph and saying, how do we fix it? And it's very obvious to me, being in the storage industry, where this is coming from. And we talked about the scope 3 is, the emissions that are from the stuff that they're purchasing, this capital goods and purchase goods and services. When they're buying SSDs, when they're buying DRAM, when they're buying CPUs, they have to take that as scope 3. And so another point of research is this really nice paper done by Carnegie Mellon and Microsoft Azure, kind of looking at the operational and the title of the paper is called A Call for Research on Storage Emissions. And what the paper found was that the storage racks in Azure accounted for 33% of the operational carbon, which makes kind of sense if you think about just the footprint and energy use comparatively of storage in an Azure data center, but 61% of the embodied carbon. And they basically used some LCAs, leveraging IMEC and MakerSite. I have a comment here, it's likely much worse. I did actually talk to the folks at MakerSite. There's one of these software as a service companies that does this like AI, LCA methodologies, and I asked them about first-party data on stuff like NAND flash and memory, and they're like, well, we don't really have it exactly. We use some of the semiconductor analysis, and so it's probably worse than this. And then in the paper they say, hey, we suggested an extension of use and second life, to reduce the impact. In Intel last year at the keynote said something along the lines of like, modularity can reduce the impact of embodied carbon by 30%. Circular Drive Initiative, we have a paper that basically says that, that circularity can reduce the impact of embodied carbon by up to 40%, and I'll walk through some of that math. But just to put things in perspective of like how big the issue, the embodied carbon, in this rack, most of it was coming from the SSDs. And with an absence of, I hate the title of this paper. It was like the dirty secret of SSDs, talking about the embodied carbon of SSDs and flash. And some of the stuff in the paper was kind of junior about like some of the conclusions that they, for us in the storage industry was kind of silly. But like the main thing that they proved in the paper was that the embodied carbon on SSDs scales with the capacity because most of it comes from the manufacturing of the flash. And this is very similar to like memory, like a DRAM DIMM. Like the higher the capacity, the higher the embodied carbon, because these take a tremendous amount of energy, to manufacture in these fabs. And so unfortunately, there isn't a lot of great LCAs. So, I talked to these researchers who are trying to get first-party data from all these companies so they can do, like research like this, and to put together these meta-analyses of the life cycle assessment. So I just did kind of a back-of-the-napkin on Apple's sustainability report. They basically have, the embodied carbon and life cycle assessment done of an iPhone. And if you do a teardown of an iPhone, look at like 128 gigabyte iPhone versus a 256 gigabyte iPhone, they have the same BOM, but the only thing different is the flash. And so I did some math here, and my number I came up with was 59.88 grams per gigabyte. Okay, now if you look at the SSD market, just in 2024, it'll be 517 exabytes. So an exabyte is 1,000 petabytes, a petabyte's 1,000 terabytes, a terabyte is 1,000 gigabytes. So if you just put this in perspective and multiply that number times the 59 grams per gigabyte, my math is that just the SSDs alone could be 31 million metric tons of CO2e. And if we look at Meta's scope 3 at 8 million, it kind of seems like that's a reasonable number. So what do we do about it? So Semi has some guidance, and we're going to talk about how circularity can help. One of the things, Semi has some guidance that they released. And this, I like that they have some guidance because people don't really know how to do proper reporting of this. Their guidance is basically that a recertified product, would not have the embodied carbon, and that the first user, whoever the first purchaser, would take the brunt of the scope 3. And that is a nice, clean way for carbon accounting. It is one method that we think is interesting, and there's another method that we think is also interesting. This, unfortunately, doesn't solve the hyperscale problem of scope 3. I mentioned the hyperscalers have this giant scope 3 problem. This doesn't solve that problem. So it does, however, incentivize a second use for the people that are purchasing the recertified equipment. So we've done some research in this. I'm just going to give an intro. We have, I mentioned I'm the secretary of our nonprofit called Circular Drive Initiative, where we do all things sustainability and storage. Obviously one of the main barriers to reuse and storage is data security, the magnitude of data loss, and basically the magnitude of loss is perceived by one of these hyperscalers if private data were to, for instance, leak online, or somebody were to recover sensitive data. Is very bad. So thus, all the drives today basically at hyperscale data centers are being shredded to avoid the security risk, which we're trying to fix. So one of the things we are doing, we did through CDI and OCP, is we basically wrote a blog post on the CDI blog. Smith & Associates is one of our members, and they do some of the ITAD work for one of the largest hyperscalers in the hard drive space. And they wrote a nice little blog on our website. You can go check it out. And this is eventually going to be a nice white paper that we're going to produce here, talking about some of the merits of carbon accounting and circularity. But what they did was they interviewed a bunch of CDI and OCP members, some of which were hyperscalers, and most of which did not want to be named in the paper, wanted to stay anonymous. But they did give a lot of really good insight. One of the things I mentioned was this challenge of the carbon accountability, like where does the scope 3 go? Why is it's not really fair if the hyperscaler uses it for a couple years and then sells it, and they have to take the brunt of the scope 3. That doesn't make sense. This amortization, this idea of, it makes sense, from an efficiency standpoint. Like if you can just use a thing for 10 years instead of 5 years, it obviously makes sense that the per year emissions are lower. It's half. And so how do you take credit for that? Well, if you just take the scope 3 when you buy the thing, then none of this amortization matters. So that was obviously a problem. They also highlighted what I just mentioned, which is security is definitely the number one barrier to circularity. I think storage is a really good case study because we think storage is actually probably the hardest market. And once we unlock circularity in storage, stuff like DRAM and CPUs and memory, all that stuff is much easier because it's not holding persistent customer data. The one thing that was kind of interesting to me is, again, I don't do sustainability in the greenhouse gas reporting for my day job, so I didn't have really heard of carbon insets. I did work on a blockchain project that did like carbon credits, and so I was kind of familiar with some of that carbon market and carbon trading. But after talking to some of these people that do these carbon offsets and carbon market, I quickly realized that this is a very deep topic, and I'm never going to, only going to be able to scratch the surface. But this was the first time I heard about these insets, which is like within the company's supply chain. So yeah, take a look at the blog, and one of the things we'll do is hopefully make a nice white paper with OCP by the end of in Q4 that highlights some of these challenges. One of the other main barriers that we found for circularity was the health. People are always like, okay, how long does this thing last? So we wrote an academic paper on one of the ITAD partners that we work with at CDI, Interact. This paper, they decommissioned 117,000 drives. Basically, we ran some of our new software that we developed for CDI. We have a bunch of storage expertise about the health and reliability of storage devices, and we built it into a tool. And they ran this tool and found out that out of these drives, 87% of them were suitable for reuse. And then I mentioned, unfortunately, only about 5 to 10% of drives are in fact reused. So this is a clear mismatch. This was all, my participation in this paper was mostly to help educate the industry. I find that people always want to talk about like life cycle, number of years of life of a device, and that's not the way that storage people talk about reliability. We talk about AFR, MTBF. It's a probability of distribution. So we have to kind of marry the two and figure out how we communicate how this stuff actually works, so that people can design systems that are durable for used storage. And so this was, again, maybe it's more nuanced than this, but this is what the work group came up with so far, which was that maybe there's more options than this, but the first option, this no impact for circularity, is kind of where we live today, where if you're a data center operator and you buy a thing, the first user takes 100% of the embodied carbon on their scope 3, and the incentives are if you can sell your thing, then you get value recovery. If you want to do circularity, then you can get some money back for selling the devices. And the problem is what we already talked about, which is ICT devices have extremely high embodied carbon, and then thus the hyperscalers have this huge scope 3 problem. So this doesn't solve our problem. So we thought amortization, if you could amortize the embodied carbon over a device over 10 years, and then you could understand the embodied carbon per year, and then the first user could take a certain percentage of that, and then the second user could take the other percent. Say, the problem with this is that I mentioned the standardization, the understanding of like how long these things last is not very good. Meaning we can make a statistical model of what the average lifespan of these devices are, but like for that one thing, that specific thing that they bought, how do they do that accounting? Do they pick 8 years? Do they pick 9 years? Do they pick 7 years? So there are a bunch of real challenges with doing this, but conceptually everybody kind of agrees this makes sense. Like it's more of a common sense thing where it doesn't make, it's not fair that the first user takes all the scope 3. And then that third one is kind of where we mentioned that it is nice that the semi-methodology right now mentions that if you're at the perspective of a second user, you're buying recertified equipment, you can have carbon neutral or low embodied carbon gear, which is very nice. So that's also a nice incentive, but again, it doesn't solve the scope 3 problem for the hyperscalers. So So we are going to hopefully have a nice white paper by the end of the year from this work group. If you are interested in attending the work group, go to the OCP Sustainability thing and sign up for the mailing list. We have a meeting once a month. We'll probably need to do it a couple more times before the end of the year to get this white paper done. But we definitely want input from OCP member companies of like how would you deal with this problem? How are you dealing with this problem? And the goal is to produce a white paper that we can present to the Greenhouse Gas Reporting Standard to say, here's some feedback from real major companies in the ICT industry of how they'd like to see things done. This is a slide from Micron from last year. Again, this is just one of these things where we believe if you can do circularity and reuse, if you can extend the use period of a drive from 5 years to 8.5, then you could reduce this extending life by 70%, can reduce the supply chain greenhouse gas emissions by up to 40%. And this is where I mentioned if you just amortize it over a certain number of years, your front-end manufacturing, your raw materials per year go down accordingly. So obviously the use of the SSD, the power, that, that doesn't really get affected by using it longer, but it does, however, this model can help you have a mental model for how to incentivize circularity. So with that, I don't have time to talk about a lot of the barriers, but thankfully, my colleague Ari from Seagate is going to have a whole session on data security and some of the things we're tackling in OCP and CDI. Big news was that we're working on another specification to kind of solve some of these data security challenges in OCP. If you are attending some of the security tracks, they have a couple brand new technologies that are going to be extremely helpful for how we think about these roadblocks of data security for blocking circularity. And again, there's actually a session today in the OCP security track on this, what's called LOCK, or Layered Open Source Cryptographic Key Management. This is a new OCP technology to help the hyperscalers manage the cryptographic keys so that they can safely remove the data on the drive and then reuse it instead of shredding it. And this is great. We have full support from Microsoft and Google on this spec, and we're really excited about this. And then the OCP Safe is this firmware audits where they can review the source code and figure out all the vulnerabilities. And again, data security is this major barrier to circularity. So the more open we can do, the more critical vulnerabilities we can find, the more trust that these vendors have in the ability for the drives to safely sanitize and remove the data. So with that, again, we have a carbon accounting circularity meeting and project in OCP. Please join it and join the mailing list and give us your feedback. I am not an expert on some of this. I want to hear from people that are actually doing this stuff on the day-to-day. We want to write this white paper that we can potentially pitch to the greenhouse gas reporting standard to give some real feedback from the ICT industry. Yeah, I mentioned if you're in the storage industry, come check out CDI, Secure Drives, and check out what we're doing. Thanks.